Hello everyone. This is Prashanth. Let's continue with the last lecture. In the last lecture, just we have completed IoT domain specific part 1. So under IoT domain specific part 1, just I completed the applications including home automation system, and cities and environment. So under these three categories of domain, we have different applications like smart lighting under home automation, smart parking, smart lighting, different appliances available in the home. Under cities also smart parking, smart lighting, smart roads, like that we have different types of in under cities. And in environment also health monitoring system, forest fire detection system, river flood detection system, like that different applications under different from these three domain, this we discussed in the last class. So now we move entering into the remaining IoT domain specifications. Like here we have so before that, this is the objective of this topic. Explore the Internet of Things applications can span a wide range of domains, and outcomes students will identify and analyze domain specific IoT application. In order to develop real-time applications in IoT, just we use this type of theoretical part. So that is very useful to develop real-time IoT applications. So this is the outcome of students, and this is the objective. Next remaining these three under home, cities and environment is completed. So remaining these three, six, energy systems, retail, logistics, industry, agriculture, health and lifestyle. So these are the six remaining domains are pending. So let's continue with the fourth one, that is energy. So under energy we have smart grids. It is a data. What is smart grid? First, it is a data communication network integrated with the help of electrical grids that collects and data captured real time about the power transmission, distribution and consumption. So this is about the remaining these three important terms: transmission, distribution and consumption. How much energy will consume, how much energy will save, like that. Smart grid technology provides predictive information and recommendations to utilities, their supplies and their customer on how best to image power. So this is about the smart grid. Under energy, by using IoT based sensing measuring technologies, the health, equipment and integrity of the grid can be evaluated. And the smart grid technology provides predictive information, recommendation to utilize as we already know. Smart grid collects the data regarding the electricity generation first. How much amount of energy will generated from the source, and consumption. How much energy will consume, and storage, distribution and equipment health data. So these are the smart grid collect the data regarding these three: generation, consumption, storage, distribution and equipment health data. So this is about smart grid. Continue by analyzing the data on power generation. These are some specifications on smart grid. What are the features like power generation, transmission and consumption of smart grid can improve the efficiency throughout the electric system. And storage, collection and analysis of smart grids data in the cloud can help in dynamic optimization of system operations, maintenance and planning. So this is the main it help to dynamic applications of system operations and maintenance and the planning. Cloud-based monitoring of smart grids data can improve the energy usage levels via energy. So that is the one advantage. Users feedback to coupled with real-time pricing information, that is okay. Condition monitoring, data collected from power generation and transmission system can help detecting faults and predictive outages. So this is very important to know. it help in detecting faults and predicting outages of the power generation systems. So these are the some advantages. The next one under energy, renewable energy systems, IoT based integration systems integrated with the transformers at the point of interconnection measure and electrical variables and how much power is fed to the into the grid. So this is the first point. For wind energy system, closed loop controls can be used to regulate the voltage at the point of interconnection, which coordinate wind turbine output provides power support due to the variability in the output from renewable energy such as solar, wind. Integrating them into the grid can be caused grid stability and reliability problems. To ensure grid stability, one solution to simply cut off the over production. So this is about the renewable energy system under energy system. And prognostics. So it is one of the important term in the under energy. Prognostics in systems such as power grids. Real-time information is collected using specialized electrical sensor called phasor measurement units. Phasor measurement PMUs at the substations are very important term. The information received from PMUs must be monitored in real time for estimating the state of the system and predicting failures. IoT based prognostics, real time health monitoring system can predict performance of machines energy by analyzing the extent of deviation of information its normal operating profiles. In these systems such as power grids, real-time information is collected using the specialized electrical sensors called phasor measurement units. Analyzing massive amounts of maintenance data collected from sensors in energy systems, equipment can provide predictions for implementing failures. OpenPDC is a set of applications for pre-processing of streaming time series data collected for phasor measurement units in real time. So these are the about prognostics. The next one in retail. In retail also we have different applications like inventory management system. IoT system enables remote monitoring for inventory using data collected by RFID readers, radio frequency identification card. Radio frequency identification readers. IoT system using radio frequency identification has the can help inventory management and maintaining the right inventory levels. In order to maintain right inventory levels, just we use here radio frequency identification to installing on that. RFID tags attached to the products allow them to track it in the real time, so that the inventory levels can be determined accurately. Products which are low on stock can be replenished. Tracking can be done using RFID readers attached to the retail stores shelves in the warehouse. So this is about under first type of advantage in retail, that is inventory management system. In order to maintain the RFID to that we maintain RFID tags to allow them track in real time. And next smart payments. Smart payments is nothing but by using with the help of Bluetooth or with the help of POC device, point of sale devices. Just we use it is the near field communication. Based on the near field communication, we can do the smart payments with the help of cards. Solutions such as contactless payments like Wi-Fi, by using Wi-Fi just we can use powered by technology such as near field communication and Bluetooth. So that is the main thing. NFC, near field communication and Bluetooth. These are the two communication technologies to use to develop the smart payments. Smart payment solutions such as contactless payments, powered technologies such as near field communication and Bluetooth, that is okay. NFC is a set of standards for smartphones and other devices to communicate with each other by bringing them into proximity or by touching them. Customer can store the credit card information in their near field communication, enabling smart homes make payments by bringing the smart phone near the point of sale terminals. NFC may be used in combination with Bluetooth, where NFC initiates initial pairing of devices to establish a Bluetooth connection while the actual data transfer takes place in the Bluetooth. So this is about the to do the smart payment. Just we maintain the two communication technologies that are near field communication and Bluetooth. Next one, smart vending machines. So this is one of the important application under payments. Sensor is a smart vending machines monitor its operations, send the data to the cloud, which can be used for predictive maintenance. Smart vending machines connected to the internet allows remote monitoring of inventory levels, elastic pricing of products, promotions, and contactless payments using near field communication. Smartphone applications then communicate with the smart vending machines, allow user preference to the recommended and learned with time. For example, when a user moves from one vending machine to the other, the pair of the smartphone, the user preference of preference and favorite product will be saved, then the used for the predictive maintenance. Smart vending machines can communicate with each other. So if the product out of stock in a machine, the user can route it the nearest machine. For perishable items, smart vending machines can reduce the price of the expiry date near. So this is about the specifications under smart vending machine. The next one, last but one, I think logistics. Under logistics also we have different applications based on the IoT. Route generation and scheduling. The route generation and scheduling is nothing but it is a system backed by cloud, can provide first response to the cloud generation queries that can be scaled up to survey a large transportation network. The route generation and scheduling system can generate end-to-end routes using combination of route patterns and transportation modes and feasible schedules based on the availability of vehicles. IoT based system backed by cloud can provide first response to the route generation queries and be scaled up to survey a large transportation network. So this is about the route generation and scheduling of the system under logistics. Next, fleet tracking using GPS, global positioning system. With the help of global positioning system, it track the location of the vehicles in real time. So for example, where is my train app? Where is my train application? So in order to locate or in order to see the current location of train, just I am using also most of the train travelers just use the where is my train app. In that it with the help of GPS only, it can track the exact state, which station is going to move, which station is departed, which station is arrival, like that. The information we see from the where is my train app. That is with the help of GPS only. That is also one of the example of fleet tracking application. System it by using global positioning system technology to track the locations of the vehicles in real time. That is best example for that is where is my train location app. Cloud-based fleet tracking system can be scaled up on demand to handle a large number of vehicles. The vehicle location and routers data can be aggregated and analyzed for detecting bottlenecks in the supply chain as traffic congestion or on routes, assignments and generation of alternative routes and supply chain management. So there is a two option. So whether you sit in the train or you sit in by somewhere, that the just depends on the situation. Just we may use the options in train tracking system. So this is the fleet tracking. Next one, GPS, about GPS of track locations of vehicle in real time. Some of the main features that could be modern fleet manager in the fleet tracking system are the route optimization, increased productivity, driver and vehicle safety in time management. So here we have three types of fleet tracking system, that is cellular and wireless passive and satellite. With the help of these three, just we use with the help of GPS location, we can identify the exact location of the vehicles or trains, whatever. Next, shipping monitoring. Shipment monitoring. So IoT based shipment monitoring systems can use by using the help of temperature, humidity to monitor the condition to send data to the cloud. So most of the based on the application or based on the system, just we use weather. For weather, you have to identify the parameters of humidity and temperature, like that. For irrigation system, there is a correct line of water flow, like that. For every application, we have different input parameters like environment, temperature, humidity, where it can be analyzed to detect flood, food spoilage. Shipment monitoring solutions for transportation system, it allows monitoring the conditions inside the container, whatever the container inside of the material, that can be tracked by the shipment monitoring system. Example, containers carrying fresh food produce can be monitored to prevent the spoilage of food. So how much food is going to spoilage, or IoT based shipment monitoring system can use a sensor such as temperature, pressure, humidity, for instance, to monitor. So same parameters, temperature, pressure, the pressure and humidity conditions inside the container, and they send the data to the cloud where it is can be analyzed to detect food spoiling. So this is about the shipment monitoring system, real time system. And the next one, remote vehicle diagnostics. So here remote vehicle diagnostics is nothing but onboard IoT device for collecting data on vehicle operations, speed or RPM, whatever the rate per meter, speed, how much speed it will maintain, how much speed it is going to increase, the status of various vehicles subsystems. It can detect faults in the vehicles or warn of impending faults. These diagnostic systems are used on board IoT devices for controlling data on vehicle operation as such as speed, engine RPM, coolant temperature, fault code number, status of various vehicle subsystem, like that. That parameters, like these are the input parameters it can monitor. Modern commercial vehicles support on board diagnostics standards such as OBD2. Support, very important term, OBD, support to onboard diagnostic standard OBD2. So this is about the remote vehicle diagnostics under logistics. Next one, OBD system can provide real-time data, status of vehicle subsystems, and diagnostics troubles code, which allows rapidly identifying the faults in the vehicle. The IoT-based vehicle diagnosis system can send the vehicle data to the centralized server or cloud, where it can be analyzed to generate alerts, suggest remedial actions. The next one, the seventh one, agriculture. In agriculture, compulsory we need to find out irrigation system. Same, the first one, irrigation system only, smart irrigation. Smart irrigation system can improve crop yields while saving the water. Smart irrigation system can use IoT devices with the soil maturing first term. Soil mature sensor is determine the amount of moisture on the soil and release the flow of the water throughout the irrigation pipes only when the moisture levels go below a predefined threshold value. And it is also moisture level measurements on the server and in the cloud, where it is collected data can be analyzed to the plan of watering schedules. So this is the smart irrigation under agriculture domain. Next, cultivates a rain cloud is a device. This is the real-time image of the smart irrigation system. This is the mobile, by using with the help of mobile app. Just we can identify the input parameters: how much water will flow, how much humidity, how much the temperature. Like that, it can determine mature level also. For smart irrigation that uses water valves, soil sensor, and Wi-Fi enabled programmable counter to determine moisture amount in soil. Cultivates rain is a device for smart irrigation that uses water valves, soil sensors like that. It is okay. Next one, the greenhouse control under agriculture. So in order to improve productivity in the agriculture department, greenhouses are structured with the glass or plastic roofs that provide conductive environment for growth of plants. So this is the first point. In order to maintain greenhouse control or improve the productivity, the climatological conditions inside a greenhouse can be monitored and controlled to provide the best growth for the plant. So this is the second specification. The last one, temperature, humidity, soil moisture, lightning, carbon dioxide levels are also monitored using the sensors. Some gases will be released that can also detected by the IoT devices. It controls the controlling function at controlling the temperature, humidity, soil moisture, sun and carbon dioxide levels that are monitored by the sensors and conditions that are controlled automatically using the actuation devices. So the last one, IoT system play an important role in the greenhouse control, help in improving the productivity. So the main aspect, the main specification of greenhouse controller here to improve the productivity in agriculture sector. That is the important term you have to remember. Next one, the data collected from various sensors is stored in a centralized server. That is, we already know. In the cloud, where analysis is preferred to optimize the control strategies and also correlate the productivity with the different control strategies, like as shown in the figure. This is the greenhouse control center with the help of tablet application or dashboard, Amazon Echo, like that. We have to develop to improve the productivity. So these are the some important questions on IoT domain specification. Discuss the IoT application in cities, in retail, in agriculture. So just like smart irrigation system, just we discussed in the last slide only. In the home automation system, smart parking, smart lighting, smart waste, like that. In environment also, health. In environment, just river flood detection, forest fire detection, like that comes under environment. And applications in energy harvesting system, prognostics, like that comes under energy system. And the last one, logistics also, just we discussed in last slide, that is greenhouse control. So these are the some important questions under this IoT domain specific part 1 and part 2. Remaining continue with the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.